Okay, hi, Assalamualaikum and a very good day everyone. In this video, we are going to look at how to configure the input signal for our circuit in order to do the simulation. Okay, so remember in class when we do our simulation, or when we want to come up with our output waveform for our circuit, so we need to have at least the clock signal and also the data input signal, isn't it? So this is what we are going to do in this video. That is how to configure or how to construct our input signal. Okay, so let's start with our clock and data input signal. Here also we have a clear signal input, isn't it? Okay, so let's try out this one. What we need to do is click on this component, find out the voltage. Okay, so this is one way. There are many ways to do this, but I'll show you one by one. So this is one of those. Okay, so find out voltage and then click OK. Then we have this voltage source over here. So let's say we have two voltage source, one for our clock and one for our data in. Right, okay, so let's how to choose this. Okay, alright, okay, so next we put this label. Okay, so this label is for our clock, so the name must match the input signal. So now it become output because this one will be supplied to our this what we call this signal will be supplied to our input over here. Okay, so this one become output, will be supplied to input over here, and then we put our ground connected to here, and then here also must have its own ground, and this is the signal. V2 is the source for our data in. So let's put our data in. Okay, so the name must be the same so that when the output is being produced, it will be directed to the right input wire. Okay, so this one will be the output. Okay, output connected to here. Okay, so when we do simulation later on, so whatever it is generated through this voltage source, it will be direct input to the data in. Okay, so that's why the name must be the same, right? So now we should wire these two together. Okay, so these two should be wired together for the clock source. Okay, and then this is the ground. Okay, so now we have done this. How to come up with the clock pulse? Okay, so when you hover your mouse on this voltage source, right click on it. Okay, right click on it. So you will be shown with this dialog box. Okay, so what we do is click on advanced, and then choose pulse. Okay, pulse. Okay, and write down all the required information over here. So initial voltage is 0 volt, V on is 5 volt, and then let's assume the on voltage is 5. Okay, the T delay means time delay. So for example, let's say we put 1 nanosecond, and then T rise means the rise time. Okay, so 1 nanosecond. Fall time is the fall time. Okay, the delay in the fall time. Okay, so 1 nanosecond. T on is how long does the pulse is turned on in its cycle. Alright, so let's say we put 2, okay, 2 millisecond, for example, and the period is 4 millisecond. Okay, so I hope you can see this. So the period of the pulse is 4 millisecond, and the on time is 2 millisecond. Okay, so the pulse will be like this. Okay, and so on and so forth. It will continuously construct in that way. So I hope you can see this. So this is one of the options. Okay, so once we do that, then we click OK. Okay, so when you click OK, you can see that there's a information shown over here. So in order to, let's say, if you want to move the information over there, so you can click on this. Okay, see when you click, there's a handler over there, so you can move it here. so as not to confuse ourselves lah. Okay, so this is for V1. We have configured it. Okay, how about V1, the source for clock? We have configured the pulse. How about the data in? Okay, so same goes for data in. Right click on this. Okay, I show you back. Okay, so when you hover your mouse on V source over here, you can see there's a what we call this hand changing, the cursor can changing its shape, isn't it? Okay, so once it's changed like this, you can right click. Okay, and when you right click, then you will be directed with this dialog box. Click on advanced. Okay, so this is also how we can shape our pulse for data in. So let's say for now, we make what we call this a standard size, okay, or a regular pulse. All right, so initial is 0, turn on is 5 volts. So just now the delay time is 1 nanosecond. So let's say for us now is 1 millisecond. Rise time, let's say maintain 1 nanosecond. Fall time is 1 nanosecond. And then on T on. Okay, so before this, our clock signal, the period is 2 millisecond, isn't it? Sorry, the period is 4 millisecond over here. Okay, and the tick on is 2 milliseconds. So let's say for us now, our on time is 5 millisecond, and our period is 10 millisecond, for example. So let's say this is the input pulse, a regular input pulse for our data in. All right. So once we do that, then click on OK. Okay, so now we have this information given over here. Okay, so how to move the text? Sometimes the text might be a little bit disturbing for our eyes, isn't it? Okay, so you can choose this, what we call this icon drag over here. Click on this icon and then click on this text. When you click, you can see that it's already, when you click, there's a, what we call this, there's a handler over there, and you can move it around. Okay, so this is how you do everything lah. Okay, so once you had changed that, you can click on escape to make sure that it doesn't, to make it stay over there. Okay, so now we already configure our input signal. Alright, so how to simulate the circuit? This is what we are going to look at next. But before that, we have another input, isn't it, which is clear over here. So let's configure the clear input signal as well. So for clear input signal, it's the same process. Go to component, okay, clock. So for clear input signal, I will put it here. All right, over here, and then we have label. I'll put label, which is CLR, clear. Output, okay, and then we put it here. Okay, and then put the ground, okay, escape. Okay, what else? Wire. Okay, so wire these two together. And then another one is here and here. Okay, so once we do that, see our clear signal in this D flip-flop. This clear signal is active high, isn't it? Because it doesn't have bar. So this is active high. So when it is active high, so let's say we don't want it to active, so we have to put 0, isn't it? So if it is active low, if let's say we want it to not be active, we put 1, isn't it? Okay, so in this case, our clear signal, we don't want it to active at all. So what we can do is we can hover our source over here, over our mouse to this voltage source over here, right click, okay, and then put 0. Okay, 0. So when we put 0, meaning that it is not being active at all, because this is active high. Okay, so once we do this, then let's wire. This is preset. Preset also, we don't want it to active at all. Okay, and it is also active high, so we can wire these two together. Okay, so this source will be the voltage source for the clear signal. Okay, so thank you for watching. I'll see you in our next video where we will start the what we call this simulation. Okay, we will start the simulation. Okay, thank you everyone. I hope you can get some idea on how to configure the input signal for our circuit. Remember, there are two ways to configure the input signal. I'll show you inshallah in our next video as well. Okay, so this is one way. We put the voltage source. Another way is when we have the signal that is not regular for our data input. Let's say we want to put data signal which is unique, okay, which is some pattern, okay, 101011, something like that. So that is another story lah. So that one we will cover inshallah in our next video. Okay, thank you for watching. See you in our next video.